Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at enlargements and reductions. So what we're going to do is take this shape here, A, B, C, D. We're going to enlarge it by a scale factor of 2 and then a scale factor of a half. And it turns out what we will have is a very similar shape that is just a bit bigger or smaller. So to enlarge a shape like this, you need what's called a center of enlargement. That's this point O. This is basically a point that doesn't move. It's like this point is fixed and you're stretching in this direction, stretching away from O, but O will stay where it is. So how do I actually enlarge this shape by a scale factor of 2? Well, what you need to do is draw a line from the center of enlargement to each of the vertices. So next we need to measure the distance from the center of enlargement to each of the vertices. So of course your measurements will depend on how big your screen is. When you're doing this by hand, use a ruler. So we want to first enlarge this shape by a scale factor of 2. So a scale factor tells us basically how many times larger the image will be. So the original shape is this size. Then a scale factor of 2 means that our final square will be twice as large. So in order to achieve that, we need to double each of these lengths. So what I've done here for A, this distance was 4, so I extend the line another 4, so this total distance is 8. So point A ends up here after the enlargement, so we denote this by writing A dash. That means the image of A. Similarly for B, it was 7. We extend the line, so it's another 7. So 14 in total. So point B moves here. We denote it B dash. And we do similarly for C and D. So once we have plotted all of the vertices, we've moved them all, we simply join them up. So my one's not 100% accurate, I can't use a ruler on my iPad, but your one, what you should see is that this shape is exactly the same as that, but bigger. So a scale factor of 2 means this side here is twice as long as this side here, and this side here is twice as long as that side there, and so on. So it turns out the perimeter of this shape will be double that of the original shape, but the area is actually 4 times larger. So we've successfully enlarged the shape by a scale factor of 2. We've drawn a shape that has side lengths that are twice as long as the original shape. So let's now enlarge by a scale factor of half. So when we say enlarge by a scale factor of half, we're going to end up drawing a shape whose side lengths are half of each of these side lengths. So basically what we're doing is halving the shape, dividing it by 2. We're reducing the original shape ABCD by a scale factor of 2. So we're going to follow the same process here, drawing a line from the center of enlargement to each vertex, but this time we're going to halve the distance. So point A will be half as long. Instead of going 4, we're going to go 2, so it's going to be about there. And similarly B, we're going to go half along here, it's going to be about there. And then we do the same for C and D. For C, we go along 2.5 units, halfway along C, and for D, we go along this line, but only 4 units, half the distance. So once you've moved all the vertices, you just join it up, and so we have a shape whose side lengths are half that of the larger shape. This side length here will be half this side length here, and so on. So the area of this won't be a half of this. It turns out the area of the yellow shape is a quarter the area of the larger shape. So once again, make sure you use a ruler when you're doing this so you're as accurate as possible. I couldn't use a ruler here, but if you're accurate, you'll see these 3 shapes are what we call similar. They're just larger or smaller versions of each other. Each is the same shapes, they have the same angles and everything, and their sides are in proportion. In proportion means the sides here are double the sides of this shape, and the sides here are double the sides of this shape. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.